next important function that we need to build is write file. Very important function. So what is happening here? This function writes content to a file at a path relative to the working directory. First, we convert the working directory to an absolute path. Then we join it with the file path and convert that again to an absolute path. Next, we perform the same security check. If the file path doesn't start with the working directory, we return an error to prevent writing outside the project. We get the parent directory of the target file. If that parent directory doesn't exist, we try to create it using OS makeDirs function with existOK2 parameter, which creates all necessary parent directories. If creating the directories fails, we return an error. Then we try to open the file in write mode and write the content. If the write succeeds, we return a success message. If an error occurs during writing, we catch it and return an error message with details. Our next important function is run Python file. This function executes a Python file in a subprocess. First, we convert the working directory and file path to absolute paths. Then we perform the same security check. If the file path doesn't start with the working directory, we return an error. We verify the path points to an actual file, and we check that it ends with .py to ensure it's a Python file. And if any validation fails, we return an error. Then we use subprocess.run to execute the file. We pass sys.executable as the Python interpreter and the file path as arguments. We set the working directory as the current working directory for the subprocess, set a 30-second timeout to prevent hanging, and capture both stdout and stderr as texts. We built a response string starting with the standard output and standard error. If there is no output at all, we add a message indicating that if the process exited with a non-zero return code, we append that information. We return the complete output string. If the execution times out after 30 seconds, we catch that exception and return a timeout error. If any other error occurs, we catch it and return an error message. Our next function is callTool. This function looks up a function by name and calls it with the provided arguments: function name, function arg, working directory, and verbose. We use globals.get to retrieve the function from the current module's global namespace. If the function doesn't exist, we return an error message. Otherwise, we try to call the function passing the working directory as the first argument and unpacking the remaining arguments using asterisks. If a type error occurs, it usually means required arguments are missing, so we return a specific error message about that. If any other exception occurs during execution, we catch it and return the error message. This allows the agent to dynamically call any of our two function names. Our next function is getAPIResponse. This function wraps a chat completion API call with retry logic and error handling. It makes the API call resilient to temporary failures and handles model compatibility issues. We define getAPIResponse with four parameters: client, the API client, messages, the conversation history, tools, function definitions for tool calling, and max retries, defaults up to 5. We use a for loop that runs up to max retries times, giving us multiple attempts if the API call fails. Inside the loop, we wrap the API call in a try block to catch exceptions. We call client chat completion create with 3 arguments. Model from the environment variable, messages, the conversation history, and tools, function definitions. On success, we return the response immediately. If an exception occurs, we convert it to a string to inspect the error message. We check if the error indicates the model doesn't support tools or function calling. If so, we print an error message and return none immediately. No retries for this type of error. For the other errors, we check if we have retry remainings. If yes, we calculate the wait time using exponential backoff, 2 to the power of the attempt number, giving us 1 second, 2 seconds, 4 seconds, and 8 seconds, and so on. This prevents overwhelming the API with rapid retries. We print a message showing the wait time and current attempt number. Then we call timesleep to wait before the next attempt. If all retries are exhausted, we print an error message with exception details and return none. If the loop completes without a successful return, we return none as a final fallback.